Hello everyone, happy Holi to all. So today we are back again after a long time. So today we are going to learn about chemistry. So the topic that we are going to learn today are the isotopes, isobars, isostones means isotones, isoters, then isoelectric and all. So let us start. Let's erase this first. So in my previous videos, I have talked about all the elements, the atoms, what are mass numbers, what are atomic numbers, and what are all. So if you haven't watched that video, so please have a look at that first, then come here for that. So first we are going to discuss isotopes. So this isotopes, what is the meaning of isotopes? Actually, isotopes meaning is that atom of same element. What is element? Element that we see in the periodic table is element like oxygen, gold, aluminum, magnesium, zinc, iron, anything that we see is the element. So atoms of same element with different what? Different mass number. Different mass number is the isotopes. Isotopes of that element. I hope you are getting it. So this is English language that you get in the books, that atoms of same element with different mass number is the isotope of that element. Like let's take one example of suppose we are taking of oxygen. Oh, it's oxygen. So we have oxygen. What is the atomic number? It is 8. What is the mass number? It is around 16. So see, we write like this is the configuration we write. You have learned in my previous videos also. So this is 8 is the atomic number. So let us write it as atomic number, and this is the mass number. See, so here 16 is the mass number, 8 is the atomic number. What is the atomic number? Atomic number is the number of what? Number of protons. You know the subatomic particles, protons, electrons and neutrons. So one of them is protons. So protons has what charge? What charge? Positive charge. So protons have positive charge, and the number of protons is also known as atomic number, which is 8 for oxygen. So another thing we need to know is atoms, or you may say it as elements. It's better to say elements. Okay. So elements, or you may say atom, depends on elements, atoms number. It is atoms depend on proton. This element or atoms have their atomic number which depends on this atom. Let me write their atomic number. First of is atomic number. Depends on protons. The number of protons, the same is the atomic number. So what are the number of atoms in oxygen? Guess it. It's 8. Okay, so let me erase this. This is one information. You may note this. This is important. So erasing it. Okay, so it is being erased. And now let us erase this also. We know that the protons are equal as the atomic numbers. Now, what is our main topic? Main topic is about isotopes. So let me write. This oxygen may also have 8 is the atomic number, 17 as mass number. 17 as mass number, but this is of same element. See, 8, 8. If the atomic number is same, that means the element is also same. The atom is also same. The same kind of atom, like it is oxygen, this is also oxygen. This is oxygen, this is also oxygen. Another example, if we take 8 and this is 18. This is also oxygen, this is also oxygen, and this is also oxygen. What is the difference then? The difference is 18, 17, 16. What are these? These are mass numbers. So, different mass numbers but of the same element are known as isotopes. So, congratulations. You have successfully learned it. So, what is it? Let's revise. Atoms of same element with different mass number is the isotope of that element. So, oxygen has atomic number same 888, but the mass number is different. It is 16, 17 and 18. So let us calculate number of protons, number of neutrons, and no need of electrons. Leave it. So protons we write as P plus. What is the P plus number? P plus number is here 8. What is the P plus number here? Also 8. What is the P plus number? Also 8. So we may say that same number of protons are there. Same number of protons are there, but different numbers of neutrons. So neutron has the neutral charge, so we don't write any charge. So n equals to what? 16 minus 8. We know that mass number is composed of what? You have learned in the previous video. Mass number is composed of the number of protons added with the number of neutrons. If the number of means if the mass number is 16, then what is the protons? We know the proton is 8, means the atomic number is 8, so protons is also 8. So 8, so 16 minus 8 is also 8. So what is the number of neutrons? Neutron is mass number minus atomic number, we get the neutron number. So neutron is 8. So here also 8. Let us write that. Now what is the neutron here? It is 17, it is 8. 17 minus 8, what is it? 9. Now here what is the neutron number? Neutron number is 18 minus 8, which is 10. So you may see that proton number is 8, proton number is 8, proton number is 8. So protons are same but neutrons differ. So these things we call this as the isotopes. These two are isotopes of these. Okay, did you get it? Very good if you get it. So now let's move on to what? Let's move on to isobars. Let us write as isobars and let us erase this too. Looking very dirty. I need to change the duster. The duster has become fully useless. Okay. So isotopes has been done. Isobars. Isobar. So what does this isobar mean? So let us write something in English. Different element having different atomic number but having same mass number. What number? Mass number. So this is obvious that different element having different atomic number but having same mass number. Different element means oxygen and magnesium. Let it be. We are taking a good example like sodium. What is sodium? Na. And what is the means atomic number on the number of protons in sodium, it's 11. And what is the mass number? Okay, what is the mass number? Mass number is, we know mass number is 23. Mass number is what? 23. But let us take one isotope of sodium. What is it? One isotope of sodium is, whose mass number will be 24. Let it be like this. And another thing, which is magnesium, Mg. What is the number of protons of the atomic number? It is 12, and it has 24 as its mass number. So 24 and 12 is the protonic number, or the atomic number, and magnesium has the mass number as 24. See, 24 and 24, it is equal. What is this? This is the mass number. This is also the mass number. This is the atomic number. This is also the atomic number. Now read the English that I have read, or the definition. Different element having different atomic number, Na and Mg, are they same? No, obviously not. So Na and Mg are not same. If their atomic number is also not same, 11 and 12. But what is same? Same is their mass number, which is 24 and 24. So this is only the isobar. Different elements having different atomic number but having same mass number is the isobars. Did you get it? So let us calculate their P plus, means protonic number, means protons are 11. Here protons are 12. What is the neutron? Neutron we know 24 minus 11. What is it? It's 13. Neutron is 13. Here what is the neutron? Its neutron is 12. See, is anything matching? Protons not same, neutrons not same. What is same? Same is the addition of protons and neutrons. So 11 plus 13 is 24. 12 plus 12 is also 24. So proton plus neutron and proton plus neutron are same in the both the cases. So this is known as isobars. Okay. So this is isobars. Let us take another example. Suppose we are taking an example of nitrogen N. So nitrogen having what? 7 as the atomic number, and 14 as what? 14 as this mass number. And let's take something else which also has the mass number as 14. Mass number as 14 and atomic number as 7. Suppose we are taking of our favorite carbon, C. C has 6 as its atomic number and 14 as, suppose I am taking carbon's isotope. I am taking carbon's isotope which has atomic number, means mass number as 14 and atomic number 6. Obviously 6 will happen, and nitrogen is 7 and 14. See, 14 and 14 are matching. 14 and 14 are matching, but the atomic number is not matching. Mass number are same, atomic number are not same. So we call it as isobars. So congratulations, you have also learned isobars. So what is that? Let's revise again. Different elements having different atomic number but having same mass number are the isotopes. So let's move on. Let us see this. Okay, so it's becoming more dirtier. I know, but what to do? Now comes isotones. Isotones. Now we have learned about isotopes, isobars. Now comes isotones. Isotones. Remember it like stones, means the stones. Just okay. So isotones, what is it? Let me write. So isotones means we have equal number of not proton, not electron. What is that? Neutron. So equal number of neutron is the isotones. So for example, what we take? We take the example as, suppose I take it has, let me use this. Let me write the definition. So different what? Different element having same number of neutrons. Different element having same number of neutrons is the isotones. Simple, just write like this. Now for example, I take carbon only. Carbon, so 6 is the atomic number, and let its mass number be 13. In general, its mass number is what? 12, and it's now 13. I'm taking. So what is the, let us write the first configuration. This P plus is 6, means proton is 6. What is the neutron? Neutron is 7. Now let us take nitrogen. So nitrogen has 7 as atomic number or the proton number, and 14 has its mass number. Okay, this is the actual means nitrogen. So now let's find P plus, which is the protonic number, means proton number. It is 7, and neutron is what? 14 minus 7, which is 7. See, neutron of this case and neutron of this case are same. So we call it as isotones. So what is isotones? Different elements having same number of neutrons is the isotones. See, carbon 6, 13, nitrogen 7, 14. These are same. So we call it as what? Isotones. Now let us take another example for betterment. I am taking, suppose it as sodium. Sodium is 11 and its atomic number is 13. Means 23, sorry. Atomic number is 11 and mass number is 23. So what is the difference? Let us find. P plus is 11. N is what? N is 12. Isn't it? Yes. So N is 12, means neutron number is 12 and proton is 11. Now let us take magnesium Mg. So it is 12 and this is 24. So what is the proton? Protons are 12. Neutrons what? 24 minus 12. It is also 12. See, neutrons in both the cases are same. So this is another example of this isotones. So different elements having same number of neutrons are isotopes. Example means isotones. Remember this. This is confusing. Isotopes, isotones, isobars. Okay, isobars is different. It will not confuse you. But isotones and isotopes may confuse you, but it is generally not. So did you get it? Congratulations, you have also learned isotones. So let us revise it again. Different elements having same number of neutrons are known as isotones. Different elements like carbon and nitrogen, are they same? No, they are not same. Carbon is different, nitrogen is also different, but they are both are non-metals. Carbon's atomic number is 6, its mass number is 13. Nitrogen's atomic number is 6, 7 and atomic number is 14. So what is the proton number? 6, neutron number 7, 13 minus 6 is 7. And here nitrogen proton number is 7, but the neutron number is also 7. Means it's 7. So 7 and 7 it's matching. So we call it as isotones. Isotones means the different elements which having the same neutrons, same number of neutrons are known as isotones. So is it clear? I hope it's clear. Let's move on. Now comes isoters. T-E-R-S. Isoters. Let us erase this. Erasing it, erasing it, erasing it, erasing it, erasing it, erasing it. Done. Now let's write something that different compounds now coming compounds. Different compounds. Compounds having same structure is referred to as isoters. Isoters. Different compounds having same structure is referred to as isoters. I think it's not visible, but I'm telling you. Different compounds, listen very carefully. different compounds having same structure, same atomic structure, same structure when we are writing it as structure. That is also that is known as isoters. So let us see what is it actually talking about. Let us take our most favorite water everywhere. Don't waste water anywhere. Okay, so H2O is water. How do we write it? We write, see, it's oxygen, one arrow, hydrogen. So we write it that's like this. Now let's move on to another one, which is H2S. What is this? Hydrogen sulfide. This smells like, we say that when eggs, eggs when the eggs are broken and the eggs are destroyed, some rubbish type of smell we get, very much bad and not healthy. That is not aromatic at all. So H2S means it smells very much dirty. It smells very much like when the eggs are destroyed, the what we say, that the bad eggs. So you are understanding, right? Okay, so H2S. So how do we write it? Is, see here, H. So see, one thing is common. What is that? Structure. See here, triangle like structure is forming. Not triangle, because here it is open. So this is the structure which is forming when we are doing like this. Okay, let us see another one. So let us take another example. NH3 PH3. This is ammonia, and this one is, so NH3, how do we write? N, 1, 2, 3, H, P, it's H. So one thing is common. What is that? Their structures are same. So what is the definition? Let's read again together. Different compounds having same structure. Having same structure is referred to isoters. Isoters means the different elements which are having same structures are known as isoters. Okay, did you get it? This is ammonia, this is phosphine. Okay, so isoters are also done. Did you understand it? If understand, then congratulations. I tell every time congratulations, you be thinking that why so, but it gives us confidence to continue our learning journey more and more. So when we say congratulations, that doesn't mean that you have won one match or you have done that thing, but it is one very much big thing that you have learned one concept which is very much important for building your base. So congratulations for that also. Okay, so isoters is done. Now let's move on to isoelectric species. I know, big name. Isoelectric. Remember electric shock? When you learn, when you pronounce this thing, electric shock happens. So isoelectric or isoelectron. Okay. So by hearing this, you are understanding, I know. Isoelectrons or isoelectric means number of electrons are same. Numbers of electrons are same. That only. What is more? So let us again erase it. This erasing part is very much boring. Don't like to erase. Okay. Now let us write this. Different elements having same electrons are called this isoelectrons or isotones. Isoelectric. Species. Species means species like fish, animal, humans, Homo sapiens, sapiens. These are all species. Okay. So now let's just take example. Without example, everything looks like boring. So one example is, let us take Na. What is Na? Sodium. Na. So Na minus. Is it so? Is Na minus possible? We say as Na minus not. We say Na plus. Because why is it so? Because Na has atomic number as 11. And we know in our previous videos I have taught you that the atomic numbers, the neon gases, neon means inert gases like helium, neon, argon, krypton, then Xe, and xenon, and these are all the inert gases which have their configuration as this, or they have shells have octet and they make Na. So you have, I think you know that thing. So it has 11. So we know that 2,6 or 10 has neon. 10 is neon, which is what? Which is inert gas. So this Na will try to become inert gas or try to become stable. This sodium is not stable, but it will try to become stable. So for becoming stable, what will he do? He will lose one electron. He will lose one electron. After losing, what will he become? He will become. We know that when the means sodium is when neutral. Neutral means the protons are equal to the electrons. These are when it is stable. But when Na, listen very carefully. So this sodium wants to become stable. So what will he do? Will he gain? No. He will lose one electron. He will say that you take. His friend wants one electron, like chlorine. Chlorine has one divide electron. So if he gets the electron, it will become what? It will get the configuration of inert gas. So he will give it to his friend chlorine, one electron. He has just given. So for his betterment only he is giving, not that his friend he is giving like that. So when he gives, so one electron is loosened. So the number of proton has increased. Proton has what charge? Positive charge. So number of positive charge means positive charge has increased. So what will the charge of the atom? It will be positive. So did you get it? Why is it where I am writing positive? So number of protons here what? Number of protons will be obviously same, but number of electrons. Electron is negative, will become 10. Let us erase the proton. We don't need proton. Why we are? Electron is what? 10. Did you get it? Sodium electron 10. Now take magnesium. Magnesium 2 minus. Is it so? Magnesium is negative. No. Magnesium is 2 plus. It is giving electrons. It is giving 2 electrons. It is giving 2 electrons. It is giving 2 electrons. What will be its electron number? Again 10. See, sodium and magnesium has their electron number same after losing 1 electron for sodium, 2 electron for magnesium. They are losing electrons. Now let's take something called carbon. Carbon 4 minus means he is doing what? He is not losing. He is taking electrons. He is taking more and more electrons. He is taking how much electrons? 4. 4 electrons he has taken. 4 electrons he has taken. What will it become? It will become 10 electrons, because we know that carbon has 6 number of electrons when it is in stable condition. After taking 4 electrons, it will become 10. So electron number is 10. Now Now comes another example like N means nitrogen. How much number of electrons does he have when it is stable? 7. It has 7, so it want to become 10. So what will he do? He will take 3 electrons more. He will take 3 electrons more and get 7 plus 3, which is 10. So again electron number is 10. Here you have many examples, many. You can make any number of examples. Okay. So these are some that has electrons number same. Sodium has this, magnesium has this, carbon has this, nitrogen has this. All these have their same number of electrons, which is known as isoelectric species. These are the isoelectric species or isoelectrons. This we know as, it is known as isoelectrons. So did you get it? So what is that? Different elements having same number of electrons. Different species having same number of electrons are known as isoelectric species or isoelectrons. So did you get it? If you get it, then final congratulations, because after this there is another thing, means there are many things, but this one is the last topic for today. So I hope you got it. So what are the things that we have learned? We have learned isotopes. What are these isotopes? Isotopes are the species, you can say isotopes are the species which is the same, it is the same atomic number, has same atomic number, means it is the same element having different mass numbers. Then isobars, different elements having same mass number. Then isotones means different elements having same number of neutrons. Then what we have said, isoters means different compounds which have same structure. Then last thing, isoelectric species, which means it doesn't mean iso, it means that the substances, different species having same number of electrons are known as isoelectric species or isoelectrons. So these are all the things that we have learned in our today's video. So thank you for today. Meeting you in the next video. For the time, be safe, be happy, and don't forget to subscribe my YouTube channel to get more videos like this. Thank you.